Vectors in 2D can be written in two forms, either Cartesian, this is also known as rectangular form, or polar form. This video is going to convert vectors from Cartesian form to polar form. First of all, Cartesian form expresses the vector in terms of the x and y coordinate grid, the components x and y. Polar form uses the vector's direction and magnitude to express the vector. So the vector can be expressed in r, length, and the angle theta, anti-clockwise from the x-axis. Theta is anti-clockwise. And the r is the magnitude of the vector. Magnitude and direction, theta. Direction. The same vector can be expressed in terms of xy. X is the horizontal and y is the vertical. Vectors can be expressed in terms of the x and y coordinate grid. Vector u, a column vector, along x and up y, can be shown. So this is its component form, or their Cartesian form, also known as rectangular form. These are the x and y components. The other way to express a vector is using its magnitude and direction. We have the same grid, but this time vector u is expressed in terms of r, its magnitude, and theta, its direction. This is known as the polar form of a vector. This is only possible for a 2D vector. We can convert a Cartesian form of a vector into polar form. So the vector u, xy, can be drawn like this, x along, y up. So if we would like to find the magnitude, it's really just a matter of using Pythagoras theorem. Pythagoras to find r. Because we have a right angled triangle and r is the hypotenuse. So r squared is x squared plus y squared. Therefore r is equal to the square root of x squared plus y squared. We always use this formula to work out r. To calculate our angle theta, theta is always anti-clockwise from the x-axis. That's this axis here. So we can calculate theta using tan. Tan theta is opposite over adjacent, so tan theta is y over x. This means that theta is always the inverse tan of y over x. Always use these formulas to convert Cartesian to polar. Example 1. U is 3, 4 in component form, and we'll convert this to polar form. We find r using x squared plus y squared, 3 squared plus 4 squared. Just square the components, take the square root. So that's the square root of 9 plus 16 square root 25, or 5. Find theta by working out the inverse tan of y over x, or 4 over 3. Theta is 53.1 degrees. Use your calculator. Then we write our vector in polar form, r angle theta. 5 angle 53.1. You could do this in radians. Just change your calculator to radian mode and do this part here in radians if you like. Example 2. We will convert u equals 27 into polar form. Calculate r, the square root of 2 squared plus 7 squared. This is the square root of 4 plus 49, square root 53. We can leave it as an exact value, square root 53, or find a decimal. Doesn't matter. Calculate theta by doing the inverse tan of y over x, 7 over 2. So theta is 74.1 degrees. We write u as square root 53 angle 74.1 degrees.